Welcome to the deep dive. Today, we're really getting into cloud computing.
Yeah.
At its core, it's kind of like using computer power. Like you use electricity, right? Pay for what you use, don't own the power plant.
Exactly. And our mission here really is to trace how we got here. How cloud computing evolved from, well, just an idea into something that completely changes how we use tech today. We want to cut through some of that jargon.
Yeah, there's a lot of it.
There is. And our sources, they give us this great narrative, from the old days of actual physical servers humming away in closets to this virtual world we're mostly in now.
And this isn't just like a history lesson for tech nerds, right?
Yeah.
Understanding this helps you make sense of everything digital today
Mm.
and maybe even see where things are going next. We found some pretty surprising moments in how this all unfolded, some real aha moments based on the stuff we read.
Definitely.
Okay, so let's dive in. Where should we start? Maybe the before times, life with actual physical servers.
Yeah, let's do that. It's almost hard to picture now, but think back to the 90s, early 2000s. If you were an organization, you basically had to build your own little data center.
Your own stacks of hardware.
Exactly. Which meant, first off, huge upfront costs, buying all those servers, the networking gear, and then you had to guess how much you'd need.
Which you probably got wrong half the time.
Often, yeah. So resources were often just sitting there, underutilized. Plus, the constant headache of maintenance, keeping it all running, patching things.
Right, you needed a whole team just for that.
Yeah.
And if your website suddenly got popular or you needed more processing power?
Forget about quick.
Yeah.
Scaling up meant ordering new servers, waiting for them, physically installing them. We're talking weeks, maybe months.
Wow, months. That's unthinkable now.
It really is. And disaster recovery, making sure you don't lose data if something goes wrong.
Oh yeah, what about that?
That often meant duplicating everything. All that expensive hardware in another physical location. It was complex and incredibly costly.
Okay, so a lot of challenges. Did people try to solve this before the cloud really took off? Our sources mentioned things like grid computing, ASPs.
Yeah, there were definitely early attempts. Grid computing, you saw that more in academic and scientific fields, trying to pool computing power from lots of machines. But it was kind of specialized. It didn't really hit the mainstream commercial world.
Okay.
And application service providers, ASPs, they were sort of precursors to SaaS. They'd host an application, you'd access it online.
Like an early version of webmail or something?
Kind of, yeah. But often they were a bit inflexible, maybe needed special software on your end. They pointed towards the future, but weren't quite there.
So let's paint a clearer picture of that pre-cloud world.
Yeah.
What kinds of systems were dominant? You mentioned mainframes earlier.
Right, mainframes. Huge centralized beasts. Very powerful for certain tasks like batch processing, but also really expensive. Access was limited, often through terminals. Big iron, big investment.
Okay, then what?
Then you had the client-server model becoming really common. This feels a bit more familiar, probably. Dedicated servers on local networks, PCs as clients.
Right, like in an office network.
Exactly. More distributed than mainframes, but you still had the same problems. Difficult capacity planning, servers sitting idle, and every company needing its own little server room or data center with all the power, cooling, security headaches that entails.
So your office closet might actually be a critical piece of infrastructure.
Could be. And then as the internet grew, you had early hosting options. Dedicated hosting, renting a whole server. Colocation, putting your own server in someone else's data center. Shared hosting cheaper, but you shared resources, sometimes noisily.
Performance issues, security worries.
Yeah, exactly. And even early virtual private servers, VPSs, which were a step towards virtualization, still had limitations in scaling and management compared to modern cloud.
And grid computing stayed mostly academic.
Pretty much. It was often about voluntary sharing of resources, specialized software, didn't quite translate to the business world broadly.
Okay, so if you had to summarize the key frustrations, the big pain points of that pre-cloud era for someone running IT.
I'd say, number one, the huge capital cost. Buying hardware that depreciates, constant refresh cycles. Number two, capacity planning was basically guesswork with long lead times.
Get it wrong, and you're either wasting money or can't meet demand.
Precisely. Number three, massive operational overhead. Staff needed just to manage the physical stuff, manual scaling. Number four, lack of agility. Trying something new required big investment in time.
Slows down innovation.
Totally. Number five, geographic limits. Setting up in multiple regions was super expensive, latency was an issue, and finally, reliability. Single points of failure were common, and building redundancy was costly.
Okay, it definitely sounds like things were ready for a shakeup.
Well,
So how do we get from that to the cloud as we know it? What sparked the revolution?
Well, the seed of the idea, this concept of utility computing, actually dates back to the 1960s. A guy named John McCarthy floated the idea of computing as a public utility.
The 60s.
Yeah.
Wow, way ahead of his time.
Absolutely. But the technology just wasn't there to make it real. It really took until the early 2000s and, maybe surprisingly, Amazon.
The online bookstore.
Yeah, they'd built this enormous, incredibly efficient infrastructure to run their own massive e-commerce site. And they realized, a lot of this computing power wasn't being used all the time, especially outside of peak shopping seasons.
So they had spare capacity.
Exactly, loads of it. And someone had the brilliant idea. What if we rented this out? So in 2006, they launched Amazon Web Services, AWS, first with S3 for storage, then EC2 for compute, offering their infrastructure on demand.
And that was the game changer.
It really was. Two things were revolutionary. First, the pay-as-you-go model. No huge upfront costs, just pay for what you consume, like your electricity bill.
Huge shift from buying servers.
Massive. And second, self-service provisioning. You could use an API or web console and spin up service, storage, whatever you needed almost instantly.
So that weeks or months wait time just vanished.
Gone. You could get resources in minutes. That unlocked incredible speed and agility.
Okay, so AWS kicks it off. Who followed? Google? Microsoft?
Yep. Google launched App Engine in 2008. Their initial focus was more on platform as a service, PaaS, meaning they provided a platform where developers could just deploy their applications, and Google handled the underlying infrastructure, scaling, all that stuff. Made life easier for developers.
Okay. And Microsoft?
Microsoft got in the game with Azure in 2010. They also started with PaaS, but quickly added infrastructure as a service. Azure, the virtual servers and storage, like AWS, Azure really targeted enterprises, focusing on integrating with existing Microsoft software and offering hybrid options.
Connecting the cloud to companies' existing data centers.
Exactly. And we really should mention Salesforce here. Even before AWS formalized Azure, Salesforce was pioneering software as a service, SaaS.
Right, their CRM, you just use it through your browser.
Yeah. No software to install on-premise. They used a subscription model, multi-tenant architecture, where multiple customers run on the same infrastructure safely and automatic updates. They really proved the as-a-service model could work at scale.
So the pieces are coming together. Then you mentioned a definition helped formalize things.
Yeah, that was important. In 2011, the U.S. National Institute of Standards and Technology, NIST, published a definition that became really influential. It nailed down the key characteristics.
Okay, what were they?
5 essential characteristics. 1, on-demand self-service. You get resources yourself automatically.
No need to call sales or support.
Right. 2, broad network access. Reachable over the internet from anywhere, basically. 3, resource pooling. The provider pools resources to serve many customers, that multi-tenant idea.
Like AWS using its servers for many clients?
Exactly. 4, rapid elasticity. You can scale resources up or down quickly, sometimes automatically, to match demand.
Get more power when you need it, release it when you don't.
Perfect. And 5, measured service. You can monitor and control your usage and your build based on that usage. Pay as you go.
That really clarifies it. And NIST also defined the types of cloud services, right? IaaS, PaaS, SaaS.
Correct. Those are the 3 main service models. IaaS is the basic building blocks, compute, storage, networking. You manage the OS, middleware, applications.
Like renting the hardware infrastructure.
Kinda, yeah. Virtual hardware. PaaS provides the platform OS, databases, development tools. You manage your application and data.
Easier for developers.
Generally, yes.
Yeah.
And SaaS is the fully baked application. You just use it. Think Gmail, Salesforce, Office 365. The provider manages everything.
Okay, that makes sense. And deployment models, public, private.
Right. 4 main ones. Public cloud. Services offered over the public internet like AWS, Azure, Google Cloud, shared infrastructure, private cloud. Infrastructure operated solely for one organization. Could be on-premise or hosted by a third party.
More control, maybe more cost.
Typically. Community cloud. Shared by several organizations with common concerns like specific security requirements, less common, and hybrid cloud, a mix of public and private clouds working together.
So you can keep some stuff in-house, use the public cloud for other things.
Exactly. Gives flexibility.
Okay, definition, models, great. But what tech actually made this possible? It wasn't just Amazon having spare servers, right?
No, several key technologies really converged. Virtualization was absolutely fundamental. The ability to run multiple virtual machines, each with its own OS, on a single physical server.
Using hypervisors, like VMware.
Yes, exactly. Hypervisors like VMware, Xen, KVM, that's what enables resource pooling and efficient hardware use. It abstracts the hardware.
Okay, what else?
Big advances in distributed computing, things like Google's MapReduce for processing huge data sets across many machines, distributed file systems like Google File System or Hadoop HDFS to store all that data.
Handling data at massive scale.
Right. And concepts like eventual consistency in distributed databases, accepting that data might not be instantly consistent everywhere, but we'll get there eventually. Plus, things like message queues for coordinating between different parts of large applications.
So lots of software innovation to manage distributed systems.
Definitely. And the data centers themselves evolved dramatically. Cloud providers built massive, highly efficient, automated data centers. Economies of scale kicked in, standardized hardware, sophisticated cooling, software-defined networking.
Making it cheaper and easier to manage huge infrastructure.
Way cheaper per unit. And finally, you just can't ignore the internet itself. Faster, more reliable broadband, lower latency, global connectivity, content delivery networks, CDNs, to cache content closer to users. All essential.
It really was a perfect storm of technologies maturing together.
Yeah.
So connecting back, how did this cloud model solve those pre-cloud headaches we talked about?
It's almost a point-by-point solution. High upfront CapEx, move to flexible OpEx with pay-as-you-go.
Okay.
Difficult capacity planning, replaced by rapid elasticity and on-demand resources.
Oh.
High operational overhead for physical gear, abstracted away by the cloud provider for IaaS, PaaS, SaaS.
Real Templar.
Lack of agility. Now you have instant provisioning, makes experimentation cheap and fast. Geographic limits. Cloud providers have global data center footprints.
Global reach instantly.
Pretty much. Reliability issues. Cloud is built with redundancy, often across multiple physical locations. It just fundamentally changed the economics and speed of IT.
A true paradigm shift, as you said. Okay, so the cloud is born. It starts replacing the old way. What happened next? Did it just get bigger, or did it change qualitatively? Let's talk about the cloud growing up.
Oh, it definitely changed. After that initial phase, say post-2012 or so, we saw this incredible explosion in the types of services offered. It went way beyond just basic compute and storage.
Like what?
Databases became incredibly specialized. You didn't just get a generic database. You got managed services for relational databases, NoSQL databases for flexible data models, in-memory caches for speed, massive data warehouses, time series databases for IoT data, graph databases.
A specific tool for every data job.
Pretty much. And the whole analytics and big data space just blew up on the cloud. Managed Hadoop and Spark clusters, data processing pipelines, data lakes for storing raw data, dedicated machine learning platforms, business intelligence tools, all as services.
Making complex data analysis much more accessible.
Hugely. Then you got tons of application-level services, message queues to connect different software components, API gateways to manage access to your services, manage search services, notification systems.
Building blocks for modern applications.
Exactly. And security, naturally, became a huge focus, especially services for managing user identities, IAM, managing encryption keys, protecting against denial of service attacks, DDoS, web application firewalls, WFFs, security monitoring, SIEM, tools for compliance.
Security as a service layer throughout.
Right. Even media services took off CDNs for fast video delivery, video encoding services, live streaming platforms, AI for analyzing media content. The catalog just kept growing and growing.
It sounds like the cloud provider started offering not just the infrastructure, but also sophisticated tools built on that infrastructure.
That's a great way to put it. And alongside this service expansion, we saw a major shift in how applications themselves were being built and deployed, driven by containers.
Docker.
Docker, exactly. It emerged around 2013 and made containers accessible. Containers are like lightweight VMs, packaging an application and all its dependencies together.
So it runs the same way anywhere.
That's the goal. Consistency from developer laptop to production, super portable. But then you need a way to manage thousands of these containers. That's where orchestration came in.
Kubernetes.
Kubernetes, or K8s, became the de facto standard. Originally developed at Google, it automates deploying, scaling, and managing containerized applications. It's complex, but powerful.
So cloud providers started offering managed Kubernetes.
Absolutely. AWS has EKS, Azure has AKS, Google has GKE. They run the complex Kubernetes control plane for you, making it much easier to adopt.
Okay, so containers in Kubernetes changed deployment. What about how apps are designed?
That shifted, too, towards what's called cloud-native development. It's about building apps specifically to take advantage of the cloud model.
What did that involve?
Key ideas include microservices architecture breaking large monolithic applications into smaller, independent services. Each can be developed, deployed, and scaled separately.
More flexible, faster updates.
Exactly. There's also the 12-factor app methodology, a set of best practices for building robust and scalable cloud apps, covering things like config, dependencies, logs, and, critically, the rise of DevOps.
Integrating development and operations teams and practices.
Right, using automation heavily. Things like infrastructure as code, IAC, to define infrastructure and configuration files, continuous integration and continuous delivery, CI/CD pipelines, to automate testing and deployment. Better collaboration, faster release cycles.
So building and running software becomes this integrated, automated flow designed for the cloud.
That's the ideal, yes. And during this growing up phase, we also saw strategies like hybrid and multi-cloud become much more common.
We touched on hybrid mixing public and private. Why multi-cloud? Using more than one public provider.
Yeah. Reasons vary. Sometimes it's to avoid being locked into a single vendor. Sometimes one provider has a specific service that's best in class for a particular need, or for extra resilience, geographic coverage.
But potentially more complex to manage.
Definitely adds complexity. And around this time, edge computing also started to become integrated, pushing compute capabilities out from the central cloud data centers closer to where data is generated or consumed.
For things like IoT devices, self-driving cars, lower latency needed.
Exactly. Reducing that round-trip time to the cloud is critical for some applications.
Okay, so the cloud matured, specialized, and we learned new ways to build for it. What about the cutting edge now, the modern cloud era?
I'd say one of the biggest trends recently is the continued rise and refinement of serverless computing, moving even further away from managing infrastructure.
We talked about face function as a service, like Lambda.
Right, Face is huge, right? Small pieces of code that run in response to events, pay only when they run, zero server management. But serverless is broader now. You have entire serverless architectures using managed services like databases, APIs, message queues that scale automatically.
So you can build complex apps without thinking about servers at all.
That's the promise. We're also seeing serverless containers platforms like AWS Fargate or Google Cloud Run let you run your containers without managing the underlying cluster or VMs.
Best of both worlds. Container portability, serverless scaling.
Kind of, yeah. And even databases are going serverless, like AWS Aurora serverless or Azure Cosmos DB serverless mode. They scale capacity up and down automatically, even to zero, and you often pay per request or per operation.
Incredibly cost efficient if your load is variable.
Potentially, yes. Though there are trade-offs like cold starts for functions that haven't run recently. Another massive trend is the deep integration of AI and machine learning.
It seems like AI is everywhere in the cloud now. It really is. Cloud providers offer comprehensive managed ML platforms, hosted notebooks, AutoML tools that automate model building, infrastructure for training massive models, specialized hardware like GPUs and TPUs.
Making ML accessible beyond just data science experts.
Definitely lowering the barrier. And then you have cognitive services, pre-trained AI models exposed via APIs. Things like image recognition, natural language processing, speech-to-text, translation.
So developers can easily add AI features to their apps without building the models themselves?
Exactly. Just call an API. Plus, the cloud platforms provide environments for developing new AI models using frameworks like TensorFlow and PyTorch, and tools for MLOps managing the whole machine learning lifecycle.
Okay, serverless AI. What about keeping all this secure in the modern era?
Security is constantly evolving too. The zero trust model is gaining a lot of traction basically. Don't trust anything by default, always verify, focus on strong identity and access control.
Assume breaches can happen. Right. DevSecOps is another big push to integrating security practices into the development pipeline, automating security checks. Cloud Security Posture Management, CSPM tools, help continuously monitor configurations for missteps and ensure compliance. And fundamentals like data encryption, key management, data loss prevention, DLP, are more critical than ever.
And with all these services, managing the cost must be a bigger deal too.
Oh, absolutely. That's led to the rise of FinOps cloud financial operations. It's a set of practices and a culture focused on understanding cloud costs, ensuring accountability, and optimizing spending.
So not just letting the bill run wild.
Definitely not. It involves using provider tools for cost visibility, setting budgets, using things like right-sizing recommendations, leveraging spot instances for non-critical workloads, implementing auto-scaling effectively. Cloud marketplaces also offer third-party tools and services, often with integrated billing.
It's like finance meets DevOps.
That's a good analogy. And finally, we're seeing even more advanced deployment patterns emerge. Things like service meshes, Istio, Linkered, which provide a dedicated layer for managing communication between microservices, handling traffic routing, security, observability.
Adding control and visibility between all those little services.
Exactly. And GitOps using Git repositories as the single source of truth for both application code and infrastructure configuration. Changes to infrastructure are made via pull requests, just like code.
More automation and auditability.
Right. And progressive delivery techniques like canary releases or blue-green deployments, often combined with feature flags, allow for safer, more controlled rollouts of new features to users.
Slowly introducing changes, monitoring impact.
Precisely. Minimizing risk.
Okay, wow. We've covered a huge amount of ground. Maybe it's worth just quickly revisiting some of those core concepts, those service models, deployment models, to make sure they're crystal clear.
Good idea. So the service models again. ISS, infrastructure, gives you the most control, like virtual hardware. PaaS, platform, abstracts the OS and middleware. You focus on code and data. SaaS, software, is the ready-to-use application.
And newer ones.
FaaS, function, for event-driven code snippets. KaaS, containers, for managing container orchestration. And BaaS, backend, provides pre-built backend services like authentication or databases.
Got it. And the deployment models,
Ah.
where the cloud lives.
Public cloud shared, pay-as-you-go, run by providers like AWS, Azure, GCP. Private cloud dedicated to one organization, maybe on-prem or hosted. Hybrid combination of public and private. Multi-cloud, using multiple public clouds.
And those other two.
Community cloud shared by a specific group, less common. And distributed cloud, extending public cloud services to various physical locations, including the edge.
Okay. And the fundamental building blocks inside the cloud.
You've got compute, VMs, containers, serverless functions, storage, object storage like S3 for unstructured data, block storage like EBS for virtual disks, file storage like EFS for shared file systems, networking, virtual private clouds, VPCs, load balancers, DNS, CDNs, identity and access management, IAM, users' roles, permissions, authentication, and monitoring management, logging, metrics, tracing, alerting.
The core components you assemble. And the pricing.
Mostly consumption-based, pay-as-you-go, but also reserved instances savings plans for discounts on committed use. Spot instances for cheap, interruptible capacity, free tiers to get started, enterprise agreements for large customers, and always think about total cost of ownership, TCO, not just the sticker price.
Right, it's more than just the compute cost. Okay, so using the cloud effectively clearly involves new ways of working. What are the key operational aspects?
Infrastructure as code, IAC, is huge. Defining your infrastructure servers, networks, databases in code using tools like Terraform or CloudFormation.
Why do that?
Consistency, repeatability, version control, automation, avoids manual configuration errors and configuration drift. It's fundamental to DevOps in the cloud.
Oh, that doubts itself.
Essential. CI/CD pipelines for automated build, test, deploy, configuration management tools like Ansible or Chef for managing system state, comprehensive monitoring and observability, not just are things up, but why are they slow, using metrics, logs, traces, and robust incident management processes.
What about security operations in the cloud?
It's about managing identities rigorously, configuring network security correctly, firewall security groups, protecting data through encryption and access controls, and constantly monitoring for threats using cloud-native security tools.
And planning for when things do go wrong. Disaster recovery.
Critical. Defining recovery time objectives, RTO, how fast you need to recover, and recovery point objectives, RPO, how much data can you afford to lose. Implementing strategies like backups, pilot light, keeping minimal core services running, or even active multi-region setups, and testing those DR plans regularly.
Sounds like a lot to manage. What are the biggest ongoing challenges people face with the cloud?
Vendor lock-in is always a concern. Becoming too dependent on one provider's specific services makes it hard to switch. Mitigation involves using open standards, abstraction layers, maybe multi-cloud.
Okay, what else?
Security and compliance are constant challenges. It's a shared responsibility model. The provider secures the cloud infrastructure, but you secure what you run in the cloud. Understanding compliance frameworks like GDPR, HIPAA is crucial.
Cost optimization is another one you mentioned.
Always. It's easy to overspend if you're not careful. Requires ongoing monitoring, right-sizing, architectural choices, and that FinOps culture. And finally, performance optimization. Ensuring your applications run well in the cloud, tuning both the app and the infrastructure.
So, significant benefits, but also requires diligence and new skills.
No.
Okay, we've looked back and looked at today. What about the future? Where is cloud computing heading next?
Well, that edge and distributed cloud trend is definitely accelerating. More compute moving closer to users and devices, integrating tightly with IoT, public cloud providers extending their platforms out to the edge, even into customer data centers sometimes.
The cloud boundary is blurring.
Exactly. Quantum computing is another fascinating frontier. We're seeing quantum as a service offerings from major providers access to quantum hardware via the cloud for research and development. Still early days, but potentially transformative.
Running quantum algorithms through a cloud API. Wild.
It is. Sustainability is also becoming a much bigger focus. Pressure on providers to use renewable energy, improve data center efficiency, offer tools for customers to track and reduce their own cloud carbon footprint.
Green cloud computing.
Right. And finally, AI is going to increasingly drive cloud operations itself. Think autonomous operations, self-healing infrastructure, predictive scaling, AI-powered security monitoring. AI helping write code, optimize infrastructure, manage governance and compliance automatically.
The cloud managing itself using AI.
That seems to be the direction. More intelligence, more automation baked in.
Okay, what a journey. So wrapping up this deep dive, we've really seen cloud computing transform from, well, a niche idea for renting servers into the fundamental way most technology is built and delivered today, from wrestling with physical hardware to consuming services on demand.
Yeah, and the key takeaway, the real aha moment for me, is that it wasn't just about moving servers somewhere else. It was a fundamental shift in the model of computing, enabling agility, scale, and innovation that just wasn't possible before.
Absolutely. And while it brings all these incredible benefits, we've also seen it comes with its own set of complexities: security, cost, potential lock-in. Understanding that whole evolution, though, really helps you get a handle on navigating those challenges today.
Totally agree. Which leads to maybe a final thought for you, the listener. How might this continued evolution, especially towards the edge, towards AI-driven automation, further change things? Think about how it could decentralize or automate more of our digital experiences. What new possibilities or maybe new challenges does that open up for us as individuals or for businesses? Which of these trends feels most significant to you? Something to ponder as the cloud keeps evolving.